So here's a video about straight line graphs, and in red there's a formula that kind of applies here. It says y equals mx plus c, and that's kind of the shape or the form that we see for equations on this topic, where the letter m represents the gradient of a straight line, the gradient, sometimes called the slope, if you watch American videos, and the c represents what we call the y-intercept, where our straight line will cross the y-axis on our grid of coordinates. Let's work through a couple of examples. First of all, a situation like this, where we are given an equation and we're asked to draw the line for that equation. So let's start with an equation y equals 2x plus 3, let's say. Okay. So y equals 2x plus 3. There's more than one way to go about this, but the way I've taught my boys, and if you watch this you probably are one of them, is to create some coordinates that you can then plot on a grid by giving some values for x and substituting them into that equation to find some values for y. And we do it like this. Create two rows, your x row and your y row, like so, okay. And create some values, just select randomly some values for x. I'll choose 0, 2, and 4. So, let's consider that equation, y equals 2x plus 3, and instead of the x, let's substitute in those values 0, 2, and 4, one at a time. So let's first of all ask ourselves, what would happen if x was 0 in this equation? Well, if x was 0, then we'd have 2 times 0 here for 2x, 2 times 0 is 0, 0 plus 3 would be 3, so our y-coordinate of x for 0 would be 3. Okay, that's easy enough to start off with. How about if x was 2? If x was 2, then 2x would be 2 times 2, which is 4, and 4 plus 3 is 7. So if x was 2, y would be equal to 7. And if, let's draw that out and start again, so it's nice and clear. And how about if x was 4? Well, if x was 4, then 2x would be 2 times 4, which would be 8. And 8 plus 3 is 11, so y would be 11. And so therefore, we've created three sets of coordinates here. We've created the coordinates 0, 3, the coordinates 2, 7. Of course, the x-coordinate always comes first, isn't it? And the coordinates 4, 11. The x-coordinate is always followed by the y-coordinate. And we could then take those coordinates and plot them onto a graph. And I'll just sketch one here. And we'll go 1, 2, 3, 4. Don't go any harder than that, do I here? And we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that'll be nicely labelled, I suppose, really sense for clarity. Our x and y axes. And we plot the points 0, 3, 0 on the x and 3 on the y, 1, 2, 3, there it is. And 2, 7 is 2 on the x, and 7, 3, 4, 5, 6, 7 on the y, so that'll be somewhere like that, won't it? And 4, 11, well, 4 on the axis here, 7, 8, 9, 10, 11 is here, and where those 2 points intersect is around about there, isn't it? And we then join those points up to form a straight line. If they don't form a straight line, we've plotted one of the points incorrectly. And that's our line, y equals 2x point plus 3. All the points in that line would share the properties of the equation y equals 2x plus 3. We did 3 points, by the way, here. We plotted 3 points in our table, rather than just 2, just to give ourselves a chance of spotting any mistakes we might have made. If we just did 2 and joined them up, that would be fine, because only 2 points can make a straight line, can't they? But by doing 3, it gives us a chance. So if we get 1 over here and the other 2 where the other 3 are, that tells us we've gone wrong on one of them. We can just check our work and make sure we got it right. So there we go. There's an example of how you can take an equation, in this case it was this equation y equals 2x plus 3, and turn it into a straight line by creating coordinates. So there are other ways of doing it. If you go onto khanacademy.com, and you will find an interesting explanation of how to do it the American way, I suppose. But there's a way that will work. Create coordinates for x and y in your little table, and then plot them on your grid and join them up to form your straight line. So that's turning an equation into a line. How about a situation where you're given a line and you're asked to find the equation for that line? Let's plot some points. Okay, let's take let's take up the coordinates. Let's take 2, 3, and let's take 4, 5. Okay, so 2, 3, there's 2 on the x, and there's 3 on the y. 2, 3 is about there, isn't it? And 4, 5, well, there's 4 on the x, and there's 5 on the y, so that would be like so. So we'll draw our line like so. So there we go. We've been given a line, and we've been asked to find its equation. It's a straight line, so we'll have an equation similar to the one we had on the previous page at the top there, circled in green. The question is, can we find our equation here? And the answer is yes, we can, actually surprisingly easily, if we remember how the equation works. We said at the start, didn't we? The m in the equation represents the gradient or slope of the line. So I'll tell you about how we can find that in a minute. And the second part, the number that comes after the value, the multiple of x, is even easier, because we said it was what was represented by the y-intercept. Now that's particularly easy when you've already got the graph drawn for you, because the y-intercept is the point where your straight line intersects the y-axis, which is the vertical axis, isn't it? So we can look at our line here, and we can see that the straight line intersects the y-axis here at 1. So our equation, and I'll start drawing it down here in blue for emphasis, is going to be y equals something x plus 1. This bit here is the y-intercept, so it's that, plus 1, okay? So we've got that part already. Now we need to work out the gradient in order to be able to know what the m bit is, the multiple of x, the coefficient. Let's have a look. To do that, what we need to do is find the gradient, and we find the gradient, I'll call it g, by measuring the vertical distance travelled and dividing that by the horizontal distance travelled, and that's between any 2 points. So we need to find 2 points on our line between which we can measure how far up and how far across we have travelled. And there are a couple of points already marked here, actually, aren't there? I drew the line by plotting these 2 points here. And these 2 points are particularly convenient because they have whole numbers for coordinates. The points here, the coordinates here are 2, 3, and the coordinates here were 4, 5. Okay, so if we measure between these 2 points marked in red, we measure the vertical distance and the horizontal distance and divide the former by the latter. That will tell us our gradient. So between the lower and the lower of the 2 points and the higher, we've gone up how far on the y-axis? We've gone up 2 squares. We've gone from 3 to 5, haven't we? 5 minus 3 is 2, so we've gone up 2 points or 2 levels on our grid. And what's the horizontal distance covered between the 2 red points? Well, we've gone across from 2 on our x-axis across to 4 on the x-axis, and that's a distance also of 2 spaces, or 2 squares. So we've travelled across between these 2 points, we've travelled across 2 spaces and travelled up 2 spaces, and 2 divided by 2 is 1, which means our gradient for this line is 1, which means over in blue with our equation, the multiple of x will be y equals 1x. So we have a final equation of y equals 1x plus 1, but of course we're a little bit more grown up than that. We know we don't need to write 1x as 1x, we can just call it x. So the equation for this line would be y equals x plus 1. So there we go. We started off by taking an equation and drawing a line in the way that we described here. And secondly, we were given a line and we calculated this equation by first of all looking to see where it went through the y-axis, and that was the second part of our equation. And the multiple of x was calculated by working out the gradient of the line in the way that we did on the left-hand side of this page.